Dari Kerja. Selamat pagi diucapkan kepada lecturer iaitu Puan Syamimi Muhammad. Pada pagi ini saya dan rakan-rakan akan membentangkan soalan set A iaitu bagi tajuk rate of change. Okay, next slide. Kita pergi kepada introductions. Introduction iaitu stationary point, local extremum points and inflection points. Stationary point ialah point on a curve where the gradient is zero. Called stationary, at this point the function is neither increasing or decreasing. The stationary point of a function y equal to f(x) are the solution to dy over dx equal to 0. Three types of stationary known as nature of stationary point. Yang pertama adalah minimum point, kedua adalah maximum point dan yang ketiga adalah inflection point. Kita tengok. Minimum point ialah d kuasa 2 y over dx kuasa 2 sama dengan positif. Iaitu kita boleh beritahu gambar graf ini adalah seperti muka senyum dan maksimum adalah d kuasa 2 y over dx kuasa 2 iaitu negatif. Graf ini akan menurun ke bawah. Yang ketiga adalah inflection point. D kuasa 2 y over dx kuasa 2 sama dengan kosong. Ia akan seperti jalur ke atas. Saya paskan slide kepada Patricia.
Terima kasih Valentina. Jadi soalan pertama, explain the solution to find the maximum, minimum or inflection point and sketch the graph for the following function. Soalan dia ada sebut y sama dengan 2x kuasa 2 tambah 8x sama dengan 8x tolak 3. Maafkan saya. Seterusnya. Okey, ini adalah jalan penyelesaian dia. Jadi, step 1, kita kena cari dy over dx from the function. So, y sama dengan 2x kuasa 2 tambah 8x tolak 3. dy over dx sama dengan 4x tambah 8. Step 2, at the stationary point, dy over dx is equal to 0. Find the value of x. At the stationary point, dy over dx sama dengan kosong. 4x tambah 8 sama dengan kosong. 4x sama dengan negatif 8, jadi x sama dengan negatif 2. Seterusnya, step ketiga adalah substitute x sama dengan negatif 2 into original function to find value of y. Jadi, x sama dengan negatif 2, y sama dengan 2 darab negatif 2 kuasa 2 tambah 8 darab negatif 2. So, y sama dengan negatif 8. Jadi, the stationary point is negatif 2, negatif 8. Step 4 pula adalah d kuasa 2y per dx kuasa 2 from the function dy over dx sama dengan 4x tambah 8. D kuasa 2y per dx kuasa 2 sama dengan 4 besar daripada kosong. Jadi, kita dapat negatif 2, negatif 8. So, it's a minimum point. So, graf kita akan jadi senyum. Seterusnya adalah graf. Okey, jadi anda boleh tengok di sini graf dia adalah tersenyum ya. Bukan sedih. So, sebab dia minimum point, so graf dia akan tersenyum. Automatik tersenyum, korang akan buat senyum. Tapi kalau selain daripada tersenyum, sedih, bengkok ke apa semua, itu ada salah. Kerana minimum point is senyum. Inilah dia. Itu saja dari saya. Seterusnya.
Okay, kita pergi ke introduction rate of change. Rate of change is used mathematically describe the percentage change in value over a defined period of time, and it represents the momentum of variable. The conclusion for ROC is simple in that takes current value of a stock or index and divides it by the value from an yearly period. Rate of change of functions. The average rate of change between two input values is the totally change the function values output values divided by the change in the input values. Rate of change in a graph. A rate of change relates a change in output quantity to a change in an input quantity. The average rate of change is determined using only the beginning and ending data. See the figure. Identifying points that mark the interval on a graph can be used to find the average rate of change. Okay, I pass to Bernard.
Okay, thank you, Valentina. So for the question 2, the question asks me to explain the solution for the rate of change problem given. Given that the height of a cylinder is 25 centimeter and the radius decreasing at the rate of 0.5 centimeter per seconds, the conclusion the rate of change of its volume when the volume is 200 pi centimeter cube. And for the solution, the volume for the cylinder given in the equation is 200 pi centimeter cube, and dr over dt is equals to negative 0.5 centimeter per seconds because it already stated in question 2 it is decreasing, so I put negative in front of 0.5, and the height is given in the question is 25 centimeter, and the formula for the volume of cylinder is pi r square time height. Okay, and for the step 1, the volume is equal to pi radius square h, which is height, and I move the square to in front, it becomes to 2 pi r times 25, and how I get the 50 is 2 times 25 becomes 50 pi r. Okay, if I finish step 1, and let's move to step 2. And step 2 is ask me to find r, and 200 pi equals to pi r square 25 centimeter, and let's just throw away the pi, and it becomes to 200 equals to radius square and times 25 centimeter, and let's move 25 to front, which is 200 divided by 25 equals to radius 2, and the answer after 200 divided by 25 is 8, and I change the position. Okay, after that let's move square to another side, becomes square root it which is square root 8. The radius is equals to 2.828, which is the answer for square root 8. Okay, I finished step 2, and let's move to step 3. Step 3 is the formula is dv over dt equals to dv over dr times dr over dt. Let's replace it. Okay, and dv over dr is 50 pi times 2.888. Okay, sorry, it's 828. I missed. Okay, here is the answer. Okay, times negative 0.5 centimeter per seconds, and let's solve 2.828 times negative 0.0 negative 0.5 first, it becomes negative 1.414. And for the answer of 50 pi times negative 1.414 is negative 70.7 pi. And pi times negative 70.7 is becomes 200 negative 222.112 meter cube per second. Okay, I finished my part and I'll pass this slide to Valentina.
The conclusion is acceleration is a measure of the rate of change the velocity of an object, and the three ways to change the velocity of an object is to change its direction, speed, or both its direction and speed. As the tennis ball moves down on the plane, the speed increases due to the parallel and perpendicular force components involved in gravity that aren't apparent when a ball is rolled on the flat surface. In this experiment, the direction of the ball is changed to a downward motion and the speed is increased by the inclination. A ball is accelerated down an inclined plane due to the inclination's ability to provide more speed than to the ball's motion. The distance traveled increases as the square of time. Acceleration is found by taking the initial velocity and subtracting it by the final velocity and dividing that value by the time taken. Okay, that's all from us. Thank you.
Thank you.